Deep within the silent expanse, beyond the familiar orbits of our planets, a visitor arrived. Not from the icy fringes of our Oort cloud, nor from the scattered disk of Neptune, but from an entirely different star. This was 2I/Borisov. A name now etched into the annals of astronomy, representing not just a discovery, but a paradigm shift. Its arrival, a cosmic whisper, carried tales of distant, unknown stellar nurseries. A profound journey, one stretching across unimaginable voids, concluded, momentarily, in our cosmic backyard. What secrets did this interstellar traveler carry? And what does its very existence tell us about the universe beyond our sun? The moment of revelation arrived in August 2019. An amateur astronomer, 2IBorisov, observed a faint smudge through his custom-built telescope in Crimea. What first appeared as a routine cometary discovery quickly revealed itself as something far more profound. Initial orbital calculations, swift and rigorous, unveiled an anomaly. Its trajectory, undeniably hyperbolic, indicated a speed that defied the gravitational embrace of our Sun. This wasn't merely a new comet. This was a messenger, an unheralded envoy from the galactic depths, signaling its alien origin with every kilometer it traveled. The defining characteristic of 2I/Borisov was its trajectory. Unlike every comet and asteroid native to our solar system, which follows elliptical or parabolic paths, Borisov carved a distinctly hyperbolic arc. This isn't just a geometric detail, it's a cosmic passport. An object on a hyperbolic trajectory possesses enough velocity to escape the Sun's gravitational pull entirely, never to return. It entered, made its closest approach, and then departed, accelerating back into the interstellar void. This single fact, quickly confirmed, solidified its status. Unequivocally, it was from beyond our cosmic neighborhood. Let's quantify this unbound nature. At its closest approach to the Sun, Borisov reached speeds peaking around 33 kilometers per second. While impressive, it's the excess velocity that tells the true story. Long before it even reached the inner solar system, its speed relative to the Sun was already approximately 32 kilometers per second, significantly higher than the local escape velocity at its initial distance. This wasn't a slow drift, it was a high-speed transit. This sheer velocity provided undeniable proof of its origin, a definitive signature of a journey spanning light years, propelled by the dynamics of a different star. As Borisov neared the Sun, its icy components began to sublimate, forming a distinct coma and tail. Telescopes around the world turned their gaze, eager to analyze its ejected material. Initial observations focused on the dust. The size and properties of these dust grains offered immediate clues. Unlike many solar system comets, Borisov's dust appeared relatively unprocessed, suggesting a formation environment untouched by strong radiation or frequent collisions. This wasn't merely rock and ice, it was pristine stardust, a direct sample from another stellar system, offering a tantalizing glimpse into its birthplace. Beyond the dust, spectroscopy revealed the gaseous composition of Borisov's coma. This is where the story deepened. Astronomers detected significantly high abundances of carbon monoxide, CO, and hydrogen cyanide, HCN, relative to water. This was unexpected. Solar system comets typically show a higher proportion of water ice. The rich CO content, in particular, points to a formation in an exceptionally cold environment, perhaps even colder than the outer reaches of our own solar nebula where typical comets form. It's a chemical fingerprint, hinting at specific thermal conditions in its progenitor protoplanetary disk. Comparing 2I/Borisov's composition to our solar system's comets paints a striking picture. Our comets, particularly those from the Oort cloud, formed closer to the Sun's protodisk, experiencing relatively warmer conditions before being ejected. Borisov, however, seemed to carry the signature of extreme cold. This isn't just a minor variation, it suggests fundamental differences in the conditions of its home star system's protoplanetary disk. Its chemical makeup acts as a time capsule, preserving the primordial ingredients and temperatures of an entirely alien stellar nursery. Despite its transient visit, observations provided estimates of Borisov's physical dimensions. Its nucleus, the solid core, was estimated to be roughly 0.4 to 1 kilometer in diameter. Not gargantuan, but substantial enough to carry vast amounts of volatiles. What was truly remarkable was its vigorous activity. Even at significant distances from the Sun, Borisov was actively outgassing, producing a coma that could span hundreds of thousands of kilometers. This sustained activity reinforced the idea of a rich, deep reservoir of volatiles, protected and preserved through its interstellar voyage. A hardy traveler, indeed. The implications of Borisov's composition extend beyond just its cold origin. Its apparently unprocessed state suggests a truly pristine object. It likely formed in the outer, colder regions of a distant protoplanetary disk, then was ejected before it could undergo significant chemical or physical alteration. This makes Borisov an invaluable scientific sample, a deep frozen archive of conditions in another star system, preserved in a state that objects within our own solar system rarely achieve. It's like receiving a perfectly preserved ancient manuscript, detailing an entirely different history of cosmic creation. While we know Borisov came from outside, pinpointing its exact origin star is a complex challenge. Astronomers have attempted to trace its trajectory backward through the galaxy, factoring in stellar motions and gravitational influences. While no single home star has been definitively identified, statistical analyses suggest it likely originated from a low-mass star in the galactic plane. This pursuit isn't just an exercise in cosmic cartography, it's an attempt to understand the dynamics of stellar ejection events and the prevalence of such rogue objects wandering the interstellar medium. The galaxy, it seems, is a far busier place than we imagined. Borisov isn't just a comet, it's a direct probe into exoplanetary systems. Its composition provides tangible evidence for the conditions under which planets and smaller bodies form around other stars. The presence of abundant carbon monoxide, for example, strengthens theories that many exoplanetary systems might have extremely cold outer regions, potentially different from our own. It provides ground truth to our models of distant protoplanetary disks, offering a data point that no Earth-based telescope or remote observation could ever replicate. It brings a piece of another star's beginning, directly to us. The term alien often conjures images of intelligent life. But Borisov embodies a more fundamental alienness, matter from beyond our Sun. Every atom, every molecule in its icy core was forged in a different cosmic crucible, under a different stellar wind. It is, by definition, extraterrestrial in the truest sense. Its presence confirms that material exchange between star systems is not just theoretical but a tangible reality. The galaxy is a vast, interconnected web, where fragments of one star's birth can journey to another, carrying with them the unique signature of their genesis. Borisov was not the first interstellar visitor. That distinction belongs to 1I/Oumuamua, discovered in 2017. But the two were profoundly different. Oumuamua was asteroid-like, lacking a detectable coma, and displayed an anomalous non-gravitational acceleration. Its shape and behavior remain a subject of intense debate. Borisov, by contrast, behaved unequivocally like a comet, actively outgassing, forming a visible coma and tail, and exhibiting a more typical cometary shape. These two objects, the only interstellar visitors we've ever definitively identified, represent two distinct archetypes, hinting at the rich diversity of objects ejected from other star systems. The discovery of Oumuamua and then Borisov has ignited a new era in astronomy, the systematic search for interstellar objects. These rare encounters provide unique opportunities to study matter from beyond our solar system directly. Future observatories, like the Vera C. Rubin Observatory, with its vast field of view and rapid scanning capabilities, are poised to discover many more. Each new detection will further refine our understanding of galactic dynamics, the prevalence of ejected material, and the diverse conditions in which exoplanetary systems are born. We are only just beginning to grasp the full extent of this cosmic exchange. 2I/Borisov, in its brief passage, served as more than just a scientific curiosity. It was a cosmic messenger, carrying a fragment of another stellar story across the immense, dark oceans of space. It demonstrated that material ejected from other star systems can indeed travel vast distances, remaining largely intact, until it offers itself for our scrutiny. These objects are not merely rocks and ice, they are capsules of information, preserving the environmental conditions and chemical heritage of their distant birthplaces. What more might these silent travelers teach us about the true diversity of the universe? Despite the wealth of data collected, 2I/Borisov leaves us with a multitude of lingering questions. What star system truly ejected it, and what were the precise gravitational dynamics at play? What other chemical signatures might it have held, undetected by our instruments? How common are such interstellar comets, and what is their total contribution to the galactic dust and ice budget? Each answer only seems to unveil deeper layers of complexity, expanding the puzzle rather than solving it. Borisov, the interstellar wanderer, departed, leaving us with more profound questions than before its arrival. The journey of 2I/Borisov, from an unknown stellar nursery to a fleeting visit in our solar system, fundamentally alters our cosmic perspective. It confirms a universe far more interconnected and dynamic than once imagined, a vast arena where fragments of creation are constantly exchanged. These interstellar objects are not merely anomalies, they are tangible proof of the galaxy's intricate dance, bringing alien materials and unprecedented data right to our doorstep. Borisov may be gone, but the reverberations of its visit continue to shape our understanding, reminding us that the universe is always sending us postcards from beyond. The universe is calling. And we are finally starting to listen.